Hi, Calculus. We are going to do the big FRQ for motion. So it says let v of t be the velocity of a particle moving along the x-axis. So what we're going to assume is that the function v of t is given. And also we're going to do write a lot of notes with the assumption that this will be calculator active. So with this, we're going to assume that that function is given, okay? And then it also says that at x equals a, the position of the particle, at time t equals a, the position of the particle is p. So that would be, we can write that as x at time a is equal to whatever that number p is. So part A, it says find the particle's acceleration at time t equals b. So I'm going to use capital A for acceleration. So acceleration at time b will be equal to the derivative of the velocity at time b. And keep in mind that if this is calculator active, we can just go math 8. But find the derivative of velocity and then plug in your time b. Part B, find the particle's position at time t equals b. So this is actually FTC rearranged because you're asked for the position at one time b, but notice up here you already have the position at time a. So what we're going to do is use FTC rearranged. So position at time b is equal to my position at time a plus how much I've moved from a to b, which will be the integral of velocity. Okay? And then keep in mind that you were given that x of a is this number p. So I can go p plus, and then I can just go math 9, right, for this piece if it's calculator active. I'm going to write that for our notes as well. All right, part C, is the particle moving towards the origin or away from the origin at time t equals a? Justify. So let's draw a little x-axis here. Here's the origin. Let's say that my position is positive 2, so it's to the right of the origin. Let's assume my velocity is also positive, and that means my particle is moving to the right. Notice in this case, my position was positive and my velocity was positive, and notice that it's moving away from the origin. Similarly, let's say my position is negative 2, and that my velocity is also some negative number, which means I'm moving to the left. So notice in this case, when position is negative and velocity is negative, I'm also moving away from the origin. So you want to check the sign of position and velocity. If they're the same, the particle is moving away from the origin. If they're opposite, then the particle is moving towards the origin. So if my position at time A and my velocity at time A have the same sign, then we're moving away from the origin. And conversely, if position and velocity have opposite signs, then the particle is moving towards the origin. All right, part D. It says, what is the particle's speed at t equals a? Do you remember that speed is the absolute value of what? Speed is the absolute value of velocity. So you're just going to find the velocity at a and then take the absolute value. All right, part E, is the speed of the particle increasing or decreasing? Note this may also be phrased as, is the particle speeding up or slowing down at t equals a? Do you remember, this is one where we also have to check the sign of two functions. Do you remember which signs we check? For this, we check velocity and acceleration. So if velocity at time a and acceleration at time a have the same sign, then our particle's speed is increasing, or our particle is speeding up. For example, if your velocity is positive, that means you're moving to the right, and if your acceleration is also positive, then that means you're moving to the right faster. Okay, if they're both negative, you're moving to the left, you're getting more negative. Okay, But if velocity at time A and acceleration at time A have opposite signs, then our particle's speed is decreasing, or our particle is slowing down. All right, part F, find all values of t for which the speed of the particle is c. Well, remember, speed of the particle is what? That is the absolute value of v of t. All right, is means equal. And then we want this to equal c. Okay, so we're going to start out with that, but now let's maybe clean this up a little bit. Let's rewrite this. Let's drop the absolute values from the left. And if I do that, what do I need to do to the right? I need to add a plus or minus, correct? So I want to see if the speed is c. That's the same as saying when the velocity is both positive c and negative c. So here's the steps, and I want you to write this down. So step 1, we're going to intersect the velocity, y equals v of t, and intersect y equals c. So you're going to graph both those. So in y1, graph v of t, in y2, graph c, see where they intersect. Okay? And then step 2, you're also going to intersect, find the intersections of the velocity and y equals negative c. Okay, because if I want to see where what I'm trying to do is I'm solving this equation, but I'm doing it graphically. The thing is, on the right side, I've got essentially two different equations. Okay, so that is going to be the strategy for part F. Make sure that you intersect both the positive c value and the negative c value, whatever that number is they give you for speed. Okay, part G, it says find the total distance traveled by the particle from time t equals a to time t equals b. All right, so total distance can never be negative. So what we're going to do here is, it's a how much question. So how much, that was our total distance from time A to B. But we have to make sure that we actually integrate speed here. Okay, so you're going to math 9 to get the integral, right? Let's also talk about how we get the absolute value in our calculators. So these are the commands. You're going to go math, of course, and then you're going to scroll over 1 to NUM for number, and then you're going to hit enter. That very first one says ABS, open parentheses, and that'll take the absolute value of whatever you put in the parentheses. Okay, so that's the total distance. Now let's compare that to part H. Part H says find the total displacement of the particle from time t equals a to time t equals b. Let's talk about the differences there. If I travel to the right for a mile and then I come straight back and travel to the left for a mile, my total distance is 2 miles, but my total displacement is 0 because I landed where I started. Okay, so your total displacement is how much you've traveled to the right minus how much you've traveled to the left, which is exactly what an integral is, right? It takes your area above the curve, your positive values, and then subtracts the area below the curve. So total displacement, if we want to see where we landed from wherever we started at A, you're just going to integrate or anti-derive or math 9 v of t. All right, if we want to find when our particle is at rest, that would be when velocity is 0. So again, our strategy here will be to intersect y equals v of t. So you can put that in y1, and y equals 0, put that in y2, see where the two intersect. They will typically give you a time interval to set your window as well. Part J, when is the particle moving to the right? When is it moving to the left? So our particle is moving to the right when velocity is positive. So if we're looking at the velocity graph, that would be when the velocity graph is above the x-axis. And conversely, moving to the left when velocity is negative. All right, so what do we think? When does the particle change direction? That would be when we change from left to right or right to left, right? Yeah, so that would be when velocity changes signs. So when the velocity graph goes from positive to negative or negative to positive. So when the velocity graph crosses the x-axis. All right, part L. So L, M, and N are all average questions. And keep in mind that you've got kind of two definitions for averages, right? You've got average value and you've got average rate of change. And actually you can apply both to M and N. For L, we can only use average value. So if I want to find the average, basically value of position, well, average value goes 1 over b minus a, integral from a to b of whatever you're trying to find the average of, which in this case is the position. Okay, so that would be how we found the average position. I can also do that for average velocity. So 1 over b minus a, integral from a to b, this is velocity. And I can do that for acceleration as well. 1 over b minus a, integral from a to b of acceleration. However, for average velocity and acceleration, you can also think of that as a rate, right? So first I want to actually do some calculus here. Let's take a look at this first one. You've got 1 over b minus a, so I'm going to keep that, Then take a look at the integral. An integral means to antiderive. An antiderivative for velocity is what? Is position. So I can rewrite that integral as position evaluated at b minus position evaluated at a. Well, that should look familiar, right? That's the average rate of change formula for position, which makes sense because velocity is the rate of change of position. Okay, and think about your units here as well. If you have position in like meters and time in seconds, this would be meters over seconds, which is a velocity unit. Okay, same thing here. I've got that 1 over b minus a, so I'm going to keep that. And then let's deal with the integral. Again, the integral means to antiderive. What is an antiderivative for acceleration? Velocity. So I would take velocity and evaluate it at b minus velocity and evaluate it at a. Once again, this is also the average rate of change of velocity, which is true. Acceleration is the rate of change of velocity, and average, because they told us average here. Again, you can think of units, take the units of velocity, like meters per second, over the units of time, and now we have velocity per second squared, for example. All right, y'all, that is it.